In this video, we're going to be looking at the Spitfire 2000 rotary scanner hooked up to the Olympus 600. This is 600D dual frequency. We're going to be looking at doing some rotary scans and some bolt holes. Now the 2000 was made back around 2000 or maybe the late 90s. This particular one was probably in somebody's attic, brand new pretty much. This is the fastest of the Staveley Nortec series of scanners. It has a range of 600 to 3,000 RPMs. This old indexing scanner that I've been making the C-scan plots with only goes up to 240 RPMs. But it indexes, so you can set it to go to the exact same depth every time you use it. So your pitch or the distance between rotary scans is exactly the same. So the PS5AL scanner was used for it was actually made for the US military, Air Force, because they demanded those critical scans. So anyway, you don't see too many of these around anymore, but they're pretty cool if you want to do C-scans. Because you can't do the C-scan terrain plots with the Spitfire or the Minimite scanners. But if you want to do those C-scans, get one of these. I've got 5 of them, maybe 6. All right, so first thing I want to do, well, first show you the probe, stainless steel. So these type of probes that don't have the expandable feet on them are used for more critical inspections, but you got to have the exact right size of the probe. Probably what they used, like in these standards I got from Boeing. These have a couple of really small axial cracks in there, plus one great big circ in the middle where they bolted the 2 plates together. So first thing I want to point out is, if you look at the tip of the probe, focus probably right here, the black spot is where the coil is, right? So even though I'm not rotating the scanner at this moment in time, the coil's still active. So if I take and put the coil right on top of my aluminum and I scan over the top of a crack, you don't get any signal, right? But what if I do it fast? Then I get a huge signal. The point of that is there's a high pass filter applied to this particular setup. When I turned the instrument on, the power link, detected the scanner and the probe. It applied a high pass filter setting. Well, one of the things you got to watch out for with high pass filters is that they're speed dependent. So if it's set up, if you set up a high pass filter and you can see your flaws grade at say 300 RPMs, if you go to 200 RPM and keep your high pass filter the same, you might not even be able to see the flaws. So make sure that whatever speed you set up the high pass filter at, you keep that speed, or you adjust the filter when you adjust your speed. So to turn on the scanner, there's a little button on the back, the green button. I'm going to press it. Now, if you watch my other videos when I made the terrain plot with the PS5AL scanner, it's actually a pretty noisy scanner. The Spitfire right now is running at, 900 RPMs. You can't even hear it. It's whisper quiet. So first we're going to do is check out my noise horizontal. So if you watch the videos on my channel, the guy from Olympus with the cool accent, he shows you how to set this thing up. So right now I must have manipulated my gain a little bit, so I'm going to change it back to 61.7 on both channels. All right. So now what I'm going to do is just hold it down to the surface of our aluminum. And the dude from the Olympus video said, adjust that so the kick goes to the right. I'm just going to move this over in front of me so I can have my hand on the scanner. Have the big leg phased over to the right. So that's basically what we've got here. Oh, shit. Never mind. I screwed my gain up again. There's a lot of back and forth with eddy current settings. You know that by now. So 54.8. I'm going to make sure they're both at 54.8. Gain. There we go. Okay, so now when I adjust the gain, they're both going up and down in tandem, which is what we want. And, you know, before the angle was set up correctly, it was probably like this, or it's probably like that. You know, there's the major kick going to the left, or the majority of the signal, but the guy from the video recommended to put the kick to the right, which is right about there. Then the next thing is, let's put the probe into a hole that's got no cracks, which is what this plate is. Let's just see what the noise does. This has got to be some kind of differential arrangement, because it doesn't give us a lot of impedance change at all when we're going from air down to the material. It's got to be differential. Right there, I mean, noise is horizontal. There's no flaws. I mean, it looks great. But the proof is going to be when we go into something with a crack, which is what this block is. It's got a great big circle in the middle, and then it's got two little short axials, probably 2 to 3 millimeters in length. I'm just going to insert the 2000 into that hole slowly, because I know there's a couple of them. So I'm all the way through the hole. Now I'm going to bring it back really slow, because I'm manually moving the probe or the scanner. So there's your first one right there. Then we've got the interface, there's the crack. And then there's a smaller one. There's a small one right there. That's the crack, that's the circ. That's basically the interface between the plates right there. And then you got that larger one right there at the far end. So what we could do here is go to the gain. Let's switch to vertical. We're just going to add in some vertical gain just to see what that does. So entering the block, there's the first one. There's the interface of the two plates. And then there's a larger one there. So there's opportunity to fine tune these settings a little bit, but you can basically see how you set one of these guys up. Just for fun, I'm going to crank this thing up to 3,000 RPMs and we'll see how loud it gets. RPMs, what's that? 50 times a second? I don't know, I don't have my calculator. Anyway, it's going around pretty fast. I'm going to put a gun on the material, see what liftoff does for us. Yeah, still going to the right. Now I'm going to slowly insert it into this block. Yeah, I can see all those cracks very easy. But you can see it definitely adjusted my high pass and low pass filters a lot. But it adjusted them automatically to the right settings. So the reason we could still see flaws is because we had the appropriate high pass filter setting for this particular speed, 3,000 RPMs.